All right, ninth graders, today we're going to work on doing acceleration problems. And from your notes, you know that acceleration is a way to either change your speed by getting faster or slower, but it is also a vector, meaning that you can change your direction. So if you're traveling in a circle, but you're going at a constant speed, you're still accelerating because the direction is changing. So here's the equation for acceleration. Acceleration equals your final velocity minus your initial velocity divided by the time. Another way to write that is in one of our little circles here. In this case, the top half of that is two things. It's the final velocity minus the initial velocity, which is the change in velocity. And then we have acceleration and time. And then again, just to remind you, VF is final velocity. VI is your initial velocity. That's the velocity that you start out at. Then you have A for acceleration and T for time. So let's do a couple example problems. Okay, first problem. If I increase my speed while biking from 7 meters per second to 11 meters per second in 3 seconds, what is my acceleration? So again, we start out this problem like we do every other problem by writing down the things that we already know and then writing down what the problem is asking us for. So it says that I am biking at 7 meters per second and I increase my speed up to 11 meters per second. So those are both velocities. The one I start out at is VI, that's V initial, and that equals 7 meters per second. The one I finish at is the 11 meters per second. Now it says that it takes me 3 seconds. 3 seconds is a time. And the final part is, what is my acceleration? So acceleration is what the question is asking us for. So now we need to know, how do we make acceleration out of these pieces? And again, I showed you this equation earlier, A equals VF minus VI over T. So I'm going to rewrite that right here. A equals VF minus VI over T. And then I'm going to substitute numbers in for each of those variables. VF was 11. VI is 7. And it's all divided by T, which is 3 seconds. All right, so 11 minus 7 is 4 meters per second divided by 3 seconds. And 4 divided by 3 is 1.33. And now what units do I use for acceleration? Well, I use the units that I have here. Nothing cancels out. And so this becomes meters per second per second. So every second, I increase my speed by 1.33 meters per second. Another way to write that is 1.33 meters per second squared. It means the same thing. Okay, let's move on to the next question. So I'm still riding my bike here, and if later a dog crosses the bike path and I need to come to a sudden stop in 0.5 seconds, then what was my acceleration during that time? Okay, so again, let's write down what we know. I'm referencing the previous problem. I know that I got up to a speed of 11 meters per second. So that's where I'm starting out. I'm starting out where I finished the last problem. But because that dog crosses the path, I have to come to a sudden stop. So I'm going to end at 0 meters per second. Anytime you're at rest or you're stopping, you're coming to 0 for your velocity. The time it takes is 0.5 seconds. So again, we're going to use the same equation. A equals VF minus VI over T. And again, just plug the numbers in. So VF is 0 meters per second minus VI, which is 11 meters per second, all over 0.5 seconds. Now, on this one, a lot of times people mix it up because they think, well, you can't subtract a big number from a smaller number. However, again, it doesn't say subtract small from big, it says VF minus VI. So we have to do it that way. So 0 minus 11 is negative 11 meters per second over 0.5 seconds. And negative 11 divided by 0.5 is negative 22 meters per second per second. So why is this answer negative? It's because you're slowing down. You're traveling at 11, you got to get to 0 super fast, so you lose 22 meters per second every second. Now you're not actually going for a full second, you're able to do it in half a second, but that's nevertheless, the negative sign is indicative of a slowing down. All right, let's take a look at an example where maybe we have some different units. All right, so let's say, for example, that the car I drive can go from 0 to 60 miles an hour in 5 seconds. What is its acceleration? All right, so what is 0? 0 is where I start, so that's my initial velocity, and that's 0 miles per hour. My second velocity is 60 miles per hour, so that's 60 miles per hour. And the time is 5 seconds. The question is, what is the acceleration? Okay, so we're going to use the same equation. Now in previous situations, I said that if your time units are not the same, that you need to convert them and make sure they are. In this situation, you don't, and let me show you what happens. So VF is 60. VI is 0, and the time is 5 seconds. So 60 minus 0, hopefully, is obviously 60 miles per hour divided by 5 seconds, and I get 12 miles per hour per second. Now I could have changed hours into seconds or seconds into hours, but I think this is instructive to understand what's going on here. You are increasing your speed 12 miles an hour every second. So if you start at 0, 1 second later you're going 12 miles an hour. 2 seconds later you're going 24. 3 seconds later you're going 36. 4 seconds later you're going 48. And then 5 seconds later you're going 60 miles an hour. So this is an okay way to finish that answer. All right, one more. Last question here. Move this over. All right, and this is more of a tricky or more of a challenge problem. If I accelerate at 2 meters per second for 10 seconds after starting at rest, then what is my final velocity? So what do I have? It says that I accelerate at 2 meters per second. So that's obviously an acceleration, 2 meters per second. It says I do that for 10 seconds. Well, 10 seconds is a time. And it says I start at rest. Okay, well, starting speed or starting velocity is VI, and that's 0 meters per second. So the question is asking, what is my final velocity? So what is VF? We'll just put it in as question mark. All right, well, you can either take the other equation that we had and rearrange it algebraically, or we can take a look at this circle right here. So let me rewrite this. Okay, so VF is in the top part here, but so is VI. But I'm going to set it up that I'm trying to find the V's. So I'm going to put VF minus VI equals, and then A and T are both known and they're next to each other, so I'm going to put those over here. They multiply. Now I'm going to start plugging my numbers in. So VF minus 0 equals 2 meters per second times 10 seconds. All right, well, VF minus 0 is just VF, okay? Anything minus 0 is just itself. 2 times 10 is 20, and one of these seconds gets canceled out. And so what I'm left with is 20 meters per second for my final velocity. All right, good luck.